switch the music. I'm sure some of you will be disappointed. Alright. Today, first 3 minutes of the stream are better than the entire stream. Wow. Wow. Alright, let's see. Today we're doing the sleep skill. Skill, sleep, whatever. Okay. We'll also probably look into a little bit more, the part of the code that comes after this. So baffled you didn't even say good morning. I did say good morning. Good morning, Jerry. Welcome. Oh god. I'm very tired though. I went to bed at a reasonable time and I guess it just didn't work. I don't know. Reasonable time, like 10 p.m. Let me see. But yeah, what was it saying? Oh, look at the one of these. I forget which one. D9ED or D9E. The thing that chooses the function that happens after the attack. Yeah, we'll look at that a bit later. So anyways, doing sleep now. We did this much of it, apparently. Let's do the rest of it. What? Wait, this function here? Oh, I see. Gotta go find where to put this. Maybe. (14A). Scroll, scroll, scroll. Somewhere around here. Maybe 4A. After these. Here we go. Uh-oh. Maybe 4-8, go to destination. Yeah, I had such a weird dream this spring, like, it wasn't about anything in particular, it was just, the setting, or the idea was weird. Like, it was just, they had a bunch of folding chairs set up for like for an event or something outdoors. I was just sitting in the chair and like daydreaming about sleeping or something like that. It was a very strange concept. Got sleep on the brain though. Let's just start writing, huh? Okay. Apparently need A here. If A B66, that skips. Oh no, it loops. So there's a while. Is it while? Where's the... How's it jump out of here? Howdy howdy. Hey Wiry, welcome, good morning. I'm confused. How does it leave this loop? Oh, there's a ret. Okay, okay. Okay, so anyways, it's not while A is if A less than 3 while true. Let me say... Probably, actually, we're just probably passing that. Label 2229. Selectable. Don't have that in here. Okay. I'm guessing this is some sort of lookup. Load C95. That's the length, right? A 149. Yes. That's the length of a monster structure. Okay, let's go ahead and do this real quick. Too big. Put that here. So it does label 2208. Call that, and then Phoenix 8 to 16 takes. Do I have that in here? Is that the other one? The other one. Multiplies A and C. and returns an HL. Okay. Times 149. Plus BC, where BC is the HL we put in, so that's plus that HL. Okay, so then that becomes plus equals. The EBCAF, okay. Go here. See what this does. Looks like we do need A. And this does not use HL, so we're just passing A to it. Okay. If RAM OXC86C, is that one, then we're going to say if that's 0, we jump to that, and if it's not, we do this. Okay. So if not, then that is if RAM OXC8A equals oh, that's the same label. Okay, so that's an OR, it's not an LF. But it does not equals. Then in the else case, just return A, I think. Yep. Alright, so here, where did it push BC? Okay. Load. Morning, that bazooka. Welcome, welcome. Alright, this is a 16-bit add to HL. So what we're doing is say return RAM of OXCA8E plus A and X7F. That's what we're doing. Okay. So huh. What's in that region? CA 8E. That looks like it's right above the first monster. Yeah, that's selectable monster 1. And then this is my character information. So somewhere between there. Up to plus 7F. That definitely gets into monster data. That's so weird. So we want a hex of OXCA 8A plus OX7F CBOD. Yeah, it gets into the middle of monster data. That's so weird. If they're gonna limit it, why would they limit it to that? Surely they don't mean to go in there. Very strange. Okay. Maybe they do, considering this is supposed to be about monster data. But, oh, you know what? It probably is signed. So I'm thinking of it as like, this is relevant data or whatever, but it's probably not. It's probably just negative. $51 bytes. Not really enough for negative, but maybe. The 7F is definitely a signed sort of thing, though. Yeah, that's true. Because when a number is negative, the topmost bit is set, and this is everything but the topmost bit. If we do that, and see, this is only 7 bits, not 8. So the 8th bit is 0. Well, okay. I see what's going on. That's not supposed to be limiting at all. It's just weird. Okay. We have done the thing. Let's go back to the sleep function. Oh, not the sleep function. This function. Okay. So We're supposed to pass A as well, but I don't see A anywhere. Oh, because I passed it up here. Gotcha, gotcha, gotcha. And then A is supposed to be less than 3. I thought it is reading that data. Okay, so if we look... Hold on, go back to the memory editor. So we're here, right? And it can be this number, this number, this number, or this number. Huh. Or E. Yeah. Wonder if that means they're all entries in there for some reason. I don't know. I'll probably actually do a sleep attack and run through it, but not yet. So yeah, we want selectable monster. +1 is CAC2. C2. I'll note what that is, of course. Selectable monster +1. Okay. Then DE equals HL. Oh, that's the return value from here. Gotcha. What you return thing? Yeah. Okay. Now label C80. Alright, what's this about? Accepts DE. Oh, this is probably a loop. BNCL. Range 4. Say A equals RAM probably. Pick the... Yeah, it was. Oh, it does take HL as well. So I say RAM HL equals RAM DE. And then we increase both of them. And then... if A equals OXAD, or A, I guess we do need to say A, OXAD, then we continue the loop. Oh. Oh, interesting. Okay, we'll have to do this differently. Because we only want to subtract B if we don't do the continue. Okay. Then after the loop, A equals RAM D, and another comparison. If those, we go to here, say RAM HL equals A HL plus equals 1 RAM HL X F0. I don't think I'm returning HL, so I'm not sure I really to do that. I'm pretty sure I'm not. It did pop. Oh, there are a lot of calls to this. I'll leave it. It's not a big deal. Okay. So this is label C9C. And then, oops, that also returns. And in the else case, here we say RAM HL equals OX to F0, where I'm sure no one remembers, F0 is the int of string byte. It's been a while since we've seen string manipulation. 8D and 8E though, I don't know. I don't think that's anything in particular. Let's find out. 8D is a period. 8E is blank. Huh. May very well not be actually dealing with text. I have no idea. Just... okay. So we're passing DE and HL to this. The HL was passed to this function. Okay. Then we increase HL until it's F0. Huh, okay. While RAM HL is not equal OX F0 equals 1. That's essentially what's happening there. And then once it does, it returns. So that's not a while loop at all. How do we get down here? Where's your reference? Oh, I see. Okay, strange. So there's just some other way to get to this code than this comparison. I'll have to think about probably very hard. Where? Exactly. 6.2, here we go. I'm gonna have to just do this as like a sub function. Yeah, I don't know how else to do it. So we're gonna call this diff label 14AB 4C. Return label this. And then in the else case, it jumps down to 6, 6. Make that there. And then, oh, did they fix it? Thank God. And there. Okay, so if B no, not B, A. It is A. Oh, okay, I get what's going on. Nice. A and 3 equals E equals 3. Then we're jumping to label that. Oh, this is the long function. the A value back into B. What is A? Oh, it's what was passed. Okay, so we're just doing a condition on this, so... That's... Let's say Elf A... No, not A. RAM OXC8 6C equals... Or no, it's just if it's true, non-zero. Then we're going up to 6.2. Say A ends here. This is loading A from B, which I think is the original A, but I'm not too sure. Yes. Okay, so we don't need to do that. Just want to be sure. Okay. Oh, God. C6C, so we're here. Okay. So in the else case of that, and 3 shall equals OX C1 CA plus and 3. And then it loads that from RAM and discards the HL value, so that goes into A. Okay. Then we compare that to FF and then discard A. Back from the original value. So LF RAM equals X. Oh wait. So if it's equal, then we discard the value. If it's not equal, we keep the value. So I'm going to implement that a little differently than it's saying. I believe. Oh wait, no. It overwrote A there. Okay, no, this is the value we want. Okay. So let's do it this. I am going to implement it the way it says. So A equals that. If A equals, well, temp. If temp equals OXFF. Wait, a little different. Yes. So if they are equal and it does this part, then we say A equals temp, so we keep the value. And then both cases go down to here. And we do another check for B7. This much later, oh god. A. Oh, I. For now, I'll say else. We'll see if that ends in a return or what. Else. Label 14AB99. And then we call 5104. Okay. 510123 label 144CB3. Oh no, these are all so long. Okay. Oh, too far. Not too far. It forgot one. Okay, where were we here? We need BB7 next. I see. So that's right there. Strange, but okay. 14A, B, 4C. Say RAM HL equals OX2F. Just gonna put it on one line so I can copy paste. Or 6, or 8, or 2. F0. I don't know why this is caps. I'm gonna think of it. Okay. Oh, lordy. Let's call it THL temporary. Let's call it temp HL. Okay. OX C1 CA. I'm calling it temp because of the push. If unclear. A equals RAM OX DB50 and 3 A equals 1, and we do this label. Drink some water. And then if it's 2, instead, we go to this label. If it's not, then we say A equals RAM HL. If A equals RAM HL, go to this label. And otherwise, increase HL again. Compare again. Oh, that's not the same one. Okay, so we're just gonna say over A RAM HL plus 1 and pretend that we don't care about the permanent increase to HL. Otherwise, we go to 18. Okay, so E3 we say A RAM HL plus 1 A equals RAM HL. Well, now we're doing different ones. We say go to here. A equals RAM 1. Then we go to I have to remember that I've been skipping these permanent increases to HL. I'll probably need to remember them. Suppose I could do them here. So that's... I did the... I already did the plus 1 equals 1 for that one. I just didn't do it for here. So HL plus equals 1. Oh, I can't do that down here. Right, and then the else case. Okay, and then ED right in here. D equals 0, HL plus equals 2. The heck is LDD? That's the one. Me. Look up. LDD. Put A into memory just HL and decrement HL. I guess that makes sense. So I suppose we can just say like that. Then we don't have to decrement anything. Oh, it decremented it again, so we don't need to do any of that. We can just say plus 2. And then if A equals RAM HL, well, then we say D plus equals 1. And then okay. HL equals 1 if A equals RAM HL again. Same thing, plus equals 1. Uh-oh. That's going here. And that's going here. Uh-oh. Are they very complicated? Not really. I can just duplicate that code, I'm fine with that. If we have the end be C11, I'd be fine with that. So let's say end of here at least is C11. Not that I need to do that right now, DB or D A RAM HL equals A RAM HL plus 1 equals XF0. Okay. We'll make sure everything goes there, but I'm pretty sure it will. 18 doesn't, but that's fine. It'll do a return itself. CB or D equals 0 return. Alright. Oh, 18's on there twice as well. A equals 1 for 09, and for E it's RAM HL with A oh no, sorry. I skipped. It's A equals 2. That's all it is. Okay. Now where was I? It was here. Yeah. Okay, so we did the inks. I should add these labels so I don't get so lost. I believe this is okay, there we go. And we can say if D, rather if not D, then it's 18, or we just do this. And then if it's A equals 1, and we do OE, A equals 2, else A equals 3. Alright, so everything. That was super long. What do we use temp-HO? That's unused. C1, CA. Oh, we're supposed to add. Plus A and 3. Where did I get DB50 from? Am I in the wrong spot? B7. A. Doesn't even belong here. Oh, it's this right here. Ah, never mind. Okay. So I just used HLICY. Should all be temp HL. But it seems like HL itself isn't used again. It's popped, so... Oh well. That's more representative, I guess. The other part I was looking at, C1CA. Does that come up again? 6-6? Where's that? Oh, I didn't finish this part. That was here. I see, I see. Ah, 14. A, B, 8. F. What's this one? So we want to call label 1 Or A, B, and 9. This feels like I've done this. I have done this. That's this, isn't it? Yeah. What's this NZ? This pop set 0 flag? I don't think so. I'm just popping flags. Oh, it's popping flags. No, it's not. Probably easy. I read this. That's popping flags. Yeah, it doesn't. Oh, it's just because it's another... I see. Something could jump here, and then it would do that check. I see, I see. Fair enough. Okay, so let me refigure this part out here, since I didn't label that. I'm pretty sure that's 8F. So... this is 8C. So if it's not really if A, is it? It's not. It's just... it's nothing. So what gets here? Only you. Now that doesn't make any sense. Alright, let me reconsider this. So we move... no, compare to FF. This one here. Temp equals FF. Temp does not equal FF. And we do the jump and we also do this. But if temp equals FF, double check the load. I'm pretty sure load doesn't set. Doesn't set any flags. So okay. So if it's equal to FF, then it will set A to B, pop BC, and go down there. This is really weird. They could have done this in like one thing. Oh, because they both want to pop BC. Okay. That's... okay, whatever. We don't care about that. We don't care about popping BC. So... this is, if temp does not equal FF. Then we do this whole jump. But then we never commit temp to A in that sense, really, because we do. Okay. I guess if we're returning A, then we do. Yes, we totally understand. You are free to ask questions. I don't understand. So I mean, I kind of understand. But it's a very confusing sequence here. So what we can say is that if temp equals FF, then we can say A equals temp, whatever, and then just do the other check. It's basically, that's pretty much exactly what it's saying. And then this is this code here. I will just go back to my ETG rainbow run. Whoa. You mentioned the rainbow thing before, but I don't remember what it was. What? 144 CP3. Okay. Ah, so we do care about the A, so I do have to do that. Okay, good. A is going in here. I don't think anything else is interested in that label. Was there? Okay. So we'll leave that return and we'll get rid of that and then put that there. And then we're going to conditionalize this entire thing. So A. Is that an Aleph? 14AB66. I beat the game a few times before you can find out. Okay. So this is more like if does not equal that, and then say just another if. We're going to have that all in. Pretty sure that's correct. Pretty sure. Okay, now back onto this. RAM OX DB60 plus A. I care about HL. As well. Because it pushes it here and then it pops it into D and then assigns it. So unfortunately, care. Say A equals RAM OX DC3C plus A. And then why is it set HL to that? Probably for this call. Yes. So DE equals HL. Just do this a little out of order. It's okay. 5. OX 500500 plus A. And then RAM OX. Oh. Sets 2 by ints. OX DB 5E DE. And we call label 97A. And we're giving it DE and HL. Wait. Set 2 by int. OX C8 3 7. Set that as DE. HL, and this is 22. And call 4101. There it is. 01. Label 104A9A. All this, I suppose it would be. An earlier bank after all. Alright. EE equals 104007. Let's just say that. Label 5F6. It's a rainbow clone run. Label DAN. This is pulling from ROM here. Oh. Okay. Label 92F. Get that in a bit. Say HL equals get to by int from OXC837. And say zero. A equals DE RAM HL. Whoa. Then does the loop and then just returns. Okay. So copying a string from ROM. Oh, I have to do increases. Um, 92F. O2. I genuinely didn't think doing the sleep function would take this long. I don't think we'll be getting to anything else. But the current bank, is that what you're saying though? Oh. Doesn't tell me. Oh, it does. It's not. No, 1 is the current bank. I think it is presuming that. So if we look at this, that's only called from there, but this one is surely called from lots of places. Okay, so line 2F for our purposes. Let's just say big. We can import GPU. That's from we can say GPD dot bank we can say GB bank and the data section is 4000. Oh, this is dot from parts. So A equals from, I think just integer will do. Twice, but I don't know that we need to do it twice. It's pulling the bank. That is a reference to the bank. That's a bank byte on whatever bank we're in. Fucking. Sorry. I absolutely hate that hotkey, and I really wish I could remove it. Wait, I probably can. I sort by key binding. This one? I was pretty sure it was control. I don't want one. I want to remove the key binding. Okay, perfect. Okay, good. It's gone. Gone forever. Family friendly. Look, I try. Sometimes I screw up. I'm sorry. And I forgot where I was. Okay. Right, I was gonna put a comment here. Grabbing the bank ID. I think the rest are just temporary aids, so we can go ahead and ignore that. OX C824 equals A. And we say HL equals RAM OX C822. HL plus equals HL plus DE. Where's DE from? Apparently has to be passed. Then what was the first ever rage quit for non-gaming? No, it's just it always bugs me because I always accidentally press it and it then tries to run nothing and it just shoots errors at me for no reason. I'm like, I know it's erroneous. I'm not trying to run it. I don't know why it's a thing. That's just annoying. So DE equals get to by int HL. And then similarly, we say HL equals X C823. To by int HL. And then it changes the bank return D. Alright. Got that done. But 97A. There we go. That was the end of 97A. Why is there a comment here? What did that actually do? Move stuff into RAM. Okay. So that set C837 and C822 C837 was used by 5F6 here, and then C822 was used here. Those were two indexes of hot and address. That was the end of that function. Okay, that was used here. Don't imagine we care about the return value from that. Any return value from that. Yeah, because this would all be clobbered. Okay, so next up we care about this. Jump there. Yeah, so that's also above everything. Put it here. Ugh. I don't know if I'll be able to get into like figuring out the percentages of this. There's just so much code to go through. That and be directly. C, C3, C plus A. Oops. Oy. Okay, so that's a jump there. Heck. B. So I guess this is for range B. A equals C. So equals D C3 C again plus A equals RAM HL FA A equals E. Then we say A equals RAM OX DB60 A equals C. A equals C jump. Otherwise D plus equals 1. And then here plus equals 1. And then the D is part, or decking the B as part of this. Okay, and just returns after that. E4 is this bit here. Okay. A equals D if A if A plus equals 1. Gonna end up, isn't it? Using B still. Okay, I'm gonna call this I. Or finishes off the loop. Essentially what that means. Beth has the fifth miss the GWM battle OST in the first 3 minutes, the highlight of the stream. A equals C. HL equals OSDC3C plus A. Seems familiar. A equals RAM. I'm just gonna do this. Same thing here. We don't need any of that, I don't think. So okay. It goes to here. If not, we say C plus equals 1 and then the B, and it just makes that loop. Now, this function is AB5E. Oh. There we go. Getting 2 minutes. Oh, love of God. Okay. A equals D plus some sort of loop here. D08. I think this is basically saying, well, it's not equal. Say HL plus equals 1. I hate this song. I'm removing this song. And we say RAM equals this A, I think. Yes. And RAM HL plus 1 equals OX F0. So it's adding this byte to the string and putting the new terminator. Okay. And then return. Okay, so in that for loop that jumps here, if that finishes, it also returns. Okay, so let's simplify this a bit. A is not needed. A is also not needed, and that A is not needed. Similarly, HL is not needed. Okay, got it. Main sounds win. I have sleep music up greater than upbeat music for this kind of work. I could play rain sounds. I wonder if what was that? My Noise would get mad at me playing rain sounds from them. The funny thing about playing nature sounds on YouTube is there's a lot of nature CDs that are in the content protection stuff. So even if you're not playing their version of nature, sometimes you'll get flagged for it. Which is absurd. Okay. I think we did it. I think we did that entire function. And that was one function from sleep. It took 2 hours. I mean, obviously I called a bunch of other functions, but that was one of 4 dives that we have to do. Even if you record the rain on your own and place it next to the mic for a nice scuff BGM. I don't know. I don't know. I have one of those sound effect mics. Those are neat looking though. Alright, let's go back up to skill seat, shall we? I was suing a person for 10 money because he bought a Nintendo Switch. No. Nintendo is weird, but not that bad. Okay. 9475. Right in here. Maybe this will be easier. This one's very simple. So we set 70 to A, 71 to A, and 2x 84 on decimal. Get the 69 one too, since it's right here. $81. $147. D doesn't need anything. Get rid of that. OX 40. 64. Getting a little sidetracked. XDD 70 HL. That's XD0. Okay. Getting sidetracked indeed. See. Go back to skills. Okay, so let's do this one. Maybe. CAF. So we say set to by int damage. Oh yeah, that's not how it works. I mean, it is how it works, but that's not how I'm doing it. We're just saying we know damage done is already a 2 by it. And we say label for a 66. And then 7 C5. Nice. And then that return anything, it does. What are the other uses of this? Turns to 8L, okay. And then this returns to A. Doesn't accept anything, and then we say RLC A, so we're getting the left side of that. Right. Ooh. I think it was this one. Yeah. So go to our notes. Compact resistant bite 2, so that's 7. A equals A. How many bits are we shifting here? 6, right? Yeah. That's 7. Just to double check. Yep, 7 is sleep. And we put that in RAM OX DB4 E and call level 1 for AADC. Uh-oh, that's a new one. Say if that can do that. And then dot 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 and say return true itself. In here attack index in use equals OS 15. That is that a skill index? Should I call that something else? What is this one? 15, yeah, sleep, okay. Maybe I should call that something else. Call it skill index in use. Or skill ID in use. Or something like that. In use skill ID? using skill ID. I'll think about it later. A equals RAM OXDB4E. It deals with that comparison later, so we do that first. I bet I see that up here too, but I will take a look at that. Okay, so seven. Do that, and then say what is CBC? Not part of this? Part down here? Who refers to you? Stop spell? How strange. Okay. Oh, that's call. This is probably the same. Yep. I see, I see. That was easier than I thought. So we just need to do 14 ADDC. Go. Being a lazy member of society. Always, always. Okay. A FA equals 3 turn. A equals E equals true C flag set. So we say real OX DB42 plus RAM OX DB88. Turn A. Was it the C flag or the Z flag? (149) C8F. Oh, Z flag. My bad. True if Z flag is set. And there be okay. Well, we did the important part. This is clearly like, this isn't the probability, but this is DB42 again. It's like the status effects, right? Of my symbol file. Oh, it's not the status effects. I don't know what that is. But this DB88, I believe, is like it's some sort of index based on the monsters. I don't know the details. Yeah, maybe that's the caster. Caster's index. So it making sure you can something. Who knows? Any event. Does these functions aha, so we can get the percentages. Good, we got that far. However, I'm not gonna do it on stream. I'll do it later today, probably tonight, and post it. Yeah, cool. Oh, we did it. We did it. I think that massive amount of code I was going through was the... it's like choosing the text or something. You'd think it would do that after. I don't know. I don't know what it's doing. Maybe it's choosing the initial like attack text. Oh well. We did it. It's done. I will get the numbers up later, and next time I really do want to look at what that after attack function does, because I'm pretty sure that like applies some of the effects, like actually commits them to the monster data, and I want to look at that. It probably also does text though. Okay. I am not gonna be here tomorrow. Well, I'm not gonna stream tomorrow. I will be here, but not streaming. And then I will see you all Saturday. Continuing more Dragon Warriors monsters grinding. Thank you for coming. Have a good day. Bye bye.